Okay, question 7. So we are shown a vertical tower, so we can assume that this is, in fact, if you look closely, there's a square. That's a right angle there. Given a couple of distances, let's get on with the question. Write down the height of the tower in kilometres. So at the moment it's in metres. Well, it's funny, we've got one in metres, one in kilometres. How many metres in a kilometre? 1,000, so we need to divide this by 1,000, so 0.328 kilometres, 1 mark. On the diagram, label the angle of elevation from B to T. So imagine you're standing here and you're looking up to T. Whoops. Then the angle that your kind of head would turn through is the angle of elevation. So it's that angle there, and it needed to be marked with an X, 1 mark. They then asked to find the size of that angle. So if we put this back on here for us, whoops. That's meant to be a triangle, it's meant to be a straight line. We've got that angle there. Let's keep these both in the same units, shall we? 0.328 as calculated in part A. Let's have a look then. We've got a right angle, so we've got a right angle triangle. We know 2 sides. We don't know the hypotenuse. We do know the adjacent and we do know the opposite. So we're going to be using tan. So we can say that tan of x is equal to opposite, which is 0.328, over adjacent, which is just 3. And then, so to get x on its own, because we're trying to find an angle, we need to do the inverse tan of that answer. So if you did that on a calculator, it came out as 0.1093 recurring, I think. And then the inverse tan of that number was 6.239. And again, to 3 significant figures, that's 6.24 units degrees, because it's an angle. For part D, we're asked to find the distance in kilometres from the top of the tower. So from here, excuse me, to the point B. So we're trying to find this length. So it's a right angle triangle. We've got 2 lengths. We're trying to find the hypotenuse. So we can say that TB, the longest side squared by Pythagoras' theorem, is equal to the sum of the square of the 2 shorter sides. It's a bit of a tongue twister. On a calculator, t squared would be 9.107584, and so on. So to get the length, I need to take the square root of that, 3.0178, and to 3 significant figures, 3.02, and it says to give it in kilometres. Well, we've already been working in kilometres, so just put a km on the end.